Welcome to Daily Papers, the podcast where we break down fascinating new research. Today, we're talking about something most of us check every single day, the weather forecast.
Right, and it feels like it's getting better and better. But behind our weather apps, a quiet revolution is happening, powered by artificial intelligence. And according to a new paper titled The Rise of AI in Weather and Climate Information and Its Impact on Global Inequality, this revolution might have a serious downside.
Exactly. We all know AI is changing everything, and climate science is no exception. AI models can learn from massive amounts of historical weather data to make predictions. They can do it faster, cheaper, and in some cases more accurately than ever before.
The old way of forecasting weather involved massive supercomputers running incredibly complex physics simulations. It's powerful, but it's slow. AI is different. It's like it looks at decades of satellite images and weather readouts and just learns the patterns. It can spot the telltale signs of a developing hurricane in a way that's almost intuitive.
And the promise is huge, not just for daily weather, but for long-term climate modeling. AI could help us predict agricultural yields, track the spread of diseases, or even spot the warning signs of climate tipping points, which are major, irreversible changes to the planet. But the authors of this paper argue that this incredible technology rests on a fragile and unequal foundation.
And that foundation is data. AI is hungry for data, and where that data comes from really matters. The paper points out a huge imbalance between what they call the global north, that's generally wealthier, industrialized nations like those in North America and Europe, and the global south, which includes lower-income nations in Africa, South America, and parts of Asia.
Let's break down how this inequality shows up. The paper looks at 3 stages: input, process, and output. The input is the data we feed the AI.
And right now, that data is incredibly biased. Think about it. Where are most of the high-tech weather stations, ocean buoys, and ground sensors? They're overwhelmingly in the global north. So the AI gets this incredibly rich, detailed picture of the weather in Germany or Japan, but a much sparser, blurrier picture of the weather in the Congo Basin or the Andes.
It's like trying to create a global restaurant guide, but 90% of your reviews are from Paris and New York. You'd end up with a guide that's pretty useless for someone in Nairobi. The AI learns the world from this skewed perspective.
Then there's the process stage. This is where the AI model is actually built and trained. To do this, you need a mind-boggling amount of computing power. We're talking about high-performance computing, or HPCs, which are basically giant warehouses full of supercomputers.
And guess where those are? Almost exclusively in the global North and East Asia. The paper highlights that access to this compute is profoundly unequal. It creates a kind of technological dependency where a handful of countries and corporations develop the AI models, and everyone else just becomes a consumer of tools that weren't necessarily built with their needs in mind.
So you have biased data going in and a biased process for building the models, which leads us to the output, the actual forecasts and climate information. And this is where it gets really concerning.
The paper points to research showing that this trend continues with AI-powered models. The benefits are unevenly distributed. Wealthier, more densely populated regions see the biggest improvements in forecast accuracy.
One study they mentioned found that a 7-day-ahead temperature forecast in a high-income country can be more accurate than a 1-day-ahead forecast in a low-income country.
Wow, let that sink in. A forecast for next week in a wealthy nation is better than a forecast for tomorrow in a poor one. And these are often the very regions that are most vulnerable to extreme weather and the impacts of climate change. They need the best possible information to prepare for floods, droughts, and heat waves, but they're getting the least reliable predictions.
And this problem goes way beyond just your daily weather app. AI is also used for what's called climate impact modeling. For example, trying to predict how climate change will affect public health. But if you're combining sparse climate data with already patchy health data from a low-income region, you risk getting seriously misleading results and driving bad policy decisions.
The paper also touches on large language models, or LLMs, the tech behind things like ChatGPT. Climate-specific LLMs are being built to help us understand scientific reports and policy documents, but if the vast majority of scientific literature is produced in and focused on the global north, the AI will inherit and amplify those biases.
So is it all bad news? Is AI destined to make things worse? The authors say no, but they argue we need a fundamental shift in our approach.
First, they say we need to move from being model-centric to data-centric. We need to stop being obsessed with just building bigger, more complex AI models and start focusing on the foundational problem, the lack of good, representative data from all over the world. Investing in more weather stations in Africa is less glamorous than building a new AI, but it might have a much bigger impact.
Second, they call for a climate digital public infrastructure. The idea is to create a sort of global public library for climate data and tools. This information is a vital public good, and it shouldn't be locked behind proprietary systems or corporate paywalls. It should be open, accessible, and usable by everyone.
And finally, they talk about changing how knowledge is created. Instead of scientists in a lab somewhere building a model and just handing it down, we need knowledge co-production. This means researchers working alongside local communities, farmers, and indigenous groups to build tools that are genuinely useful and incorporate local expertise.
Ultimately, the paper is a powerful warning. The goal of AI in climate science shouldn't just be to optimize a statistical model. AI offers unprecedented opportunities to navigate the climate crisis. But as the authors put it, speed cannot come at the expense of equity.
If we just carry on as we are, we risk building a system that automates and amplifies the very environmental injustices we're trying to fix. By focusing on better data, open access, and true collaboration, we can steer this technological revolution towards a more just and sustainable future for everyone.